Hello, and we solved this question from WASSCE Nov 2012 question 3b. It says that in the diagram, triangle PQS is right angled at Q. So we see that at a point Q, there is a 90 degrees angle here. So PQS is, of course, right angled at Q. The length PQ is 5 centimeters. That is from P to Q here is 5 centimeters. Angle SPR is y degrees. Angle SPR is y degrees. The length PS is 8 centimeters. From P to S is 8 centimeters. And angle PRQ is 52 degrees. Angle PRQ is 52 degrees. Calculate, correct to the nearest degree, the value of angle Y. So let's see how we find Y. We can approach this question, in at least two ways. Let's look at the first way that we can do that. The first way is to consider the right angle triangles. If you look at the question, we have two right angle triangles. First, we have a bigger right angle triangle. We are told that PQS is right angle at Q, so we have something like this. And then we have P here, and we have the right angle here. Then we have the point Q also here. We have S here. Okay, then we have another line running through this, that is from P to a point R. Here is 52 degrees, and then this is Y degrees. Then we have the length 8 centimeters. We have the length 5 centimeters here. All right, one way that we can solve this, if we want to find Y degrees, is first we can find this entire angle. If we can know this entire angle, bigger one, then after finding the bigger one, we now find this smaller angle. Then we subtract the blue angle from the red angle, then that will give us the angle Y. So first, let's look at the smaller, right angle triangle. So let's say considering triangle, so it will be PQR, triangle PQR. So that is triangle PQR. Now if you look at triangle PQR, let me draw it so that you see it clearly here. We have triangle PQR here, and here's P, here's Q, and there's R, so that is 90. Then we have 52 degrees here. So we are finding this angle here. Let me indicate it with the blue arc. Alright, so that is pretty simple because the sum of the interior angles of a triangle is 180 degrees. Of course, we know here 52, here is 90. So we can say that this angle here, that is the angle QPR, plus the angle here 52 degrees, plus the angle down here which is 90, should give me 180 degrees. So angle QPR, then I have to add this 90 plus that, so that should be 142, which is equal to 180 degrees. So angle QPR will be equal to 180 minus 142. So angle QPR is going to be 38 degrees here. So the angle here is 38 degrees. The blue angle here is 38 degrees. I'm now going to look at the bigger triangle. So let me look at the bigger triangle now. That is triangle PQS. Okay. Once again, I want to draw the triangle. So considering triangle PQS. So that is the bigger triangle. Right? Oh, very, very big indeed. Alright, so this Q, P, S. And let us see the angle here. The triangle PQS is covered by the red arc here, and that is the angle Y and 38. So this means the angle that we have here is going to be Y plus 38 degrees. So that is the entire angle that is covered here, and from P to Q is 5 centimeters here. So let us put the length here. From P to Q is 5 centimeters, and of course we are given the length from P to S, which is 8 centimeters. So here is also 8 centimeters. All right, so we can apply trigonometry because we're dealing with right angle triangles, and then we can find the angle here. Now we know two sides. We know this side, which is called the hypotenuse. The hypotenuse is the longest side. It is the side which is also opposite to the 90 degrees angle, and to this angle, this side is the adjacent side, because it is the side which is adjoining or near to the angle, and of course the side is the opposite side. But we know the hypotenuse and the adjacent side. We know the hypotenuse and the adjacent side, so we use by considering the mnemonic SOHCAHTOA, we can see that the AH, the K, of course we know the hypotenuse, so we will be dealing with either sine or cos. We won't be using that TOA here, but the AH tells us that of course we are going with the K, that is the cosine. So we will say that the cosine, that is cos of this angle, of the whole angle y plus 38, that is adjacent side 5 over hypotenuse 8. And then here we take cos inverse of y plus 38 is cos inverse of 5 out of 8, and y plus 38 is equal to, so we find cos inverse of 5 out of 8, and let me pull out my calculator and do that here. Okay, so say shift cos inverse of 5 out of 8, that should be that. Okay, all right, so cos inverse of this, we have 51.32. Okay, so that is to 2 decimal place. I'm very sure about that, because if you look at the calculator, it is already fixed here. If I reset it, you have a lot of decimal places. So cos inverse of 5 out of 8 here, and you are going to have a whole lot of this. So the question says we are to leave it to the nearest whole number, but we can pick it from here. 51.3178, or 0.32 is okay. That is the 2 decimal place. So let us pick that one, and we will have something like this. So we have 51.32. all right, so to find y, we subtract 38 from both sides of the equal sign. Then we have this. So we have 51.32 minus 38, so we have 51.32 minus 38, and that is what we have here, 13.32. so we have 13.32. so to the nearest whole number, we say the answer is 13 degrees to the nearest whole number. All right, so that is one way that you can solve this, and that is pretty easy. That is considering the two right angle triangles. You see that it's pretty simple. Now another way is to consider the triangle PRS. Triangle PRS is not a right angle triangle, but you can still use the sine rule to solve this question by considering triangle PRS. So that's what we're gonna do. In the second approach, instead of considering the two right angle triangles, we are just going to consider the triangle that matters, that is triangle PRS. So I'm saying considering triangle PRS. So I'm going to look at only this triangle. Okay, so P here is y degrees, and here is 8 centimeters. Here's S, then here's R. But what angle is here? I have to figure it out first. We should know the angle here, because this angle and that's on a straight line. So we say angles on a straight line sum up to 180 degrees. So we have, so this implies that angle 52 degrees plus the angle there, which should be angle PRS. Angle PRS should be equal to 180 degrees. Angle PRS should be 180 minus 52 degrees. and that should give you, I think, 180 degrees. All right, so we know the angle here as 128 degrees. Now if we can find the length here, then we can go ahead with this. Of course we can, and we have to. Now what I'm going to do is that I'm going to find the side. Okay, so I'm going to consider this right angle triangle to find the side. It's a very long way to go anyway, and PQR. So I would say considering triangle PQR. So that is triangle PQR. Let me put it that way. Okay, that is Q, that is P, and that is R. So triangle PQR will have 552 here. So here is 5 centimeters, and top here is 52 degrees. I want to find this length. Of course, this side is the hypotenuse, that is the length PR, because it is the length opposite to the 90. To this angle, it is up here, so it is facing this side. So this side becomes the opposite side, and this side, of course, becomes the adjacent side. So because I want this side and I know the opposite side, and I'm finding the adjacent side, if you compare it to the SOHCAHTOA, you see that I have to deal with the TOA, that is SOHCAHTOA, the OA. So I am not talking about hypotenuse, so it means the sine and the cos are both out here. So tan of 52 degrees is the opposite side, 5 divided by the adjacent side, the length RQ. So length RQ, make RQ the subject, that is change of subject, and you have 5 out of tan 52 degrees. So the length RQ is going to be 5 divided by tan 52 degrees. So let me pull out my calculator and type 5 divided by tan 52 degrees. All right, and I'm getting 3.9. Okay, so let me put it there. I'm getting 3.9. all right, so that is the length, 3.9 centimeters. So it means that this small side here is 3.9 centimeters. Now let me consider the bigger triangle. If I consider the bigger triangle, then I can subtract 3.9 centimeters from the length SQ and find the length here, because I want the length SR here. Okay, so let me go on again. You see that it's a very long way to go. The first one was pretty short, and I want you to use that one, but I'm just showing you that there is another way that you could do this. So PQS, considering triangle PQS, and there is a very longer way anyway. So triangle PQS here. Okay, so here I don't know the angle wise, so I'm not going to talk about trigonometry. Luckily for me, I know the length here 8 centimeters, and I know the length here 5 centimeters. So I'll talk about Pythagoras, which deals with only the size. So I'll say using Pythagoras, we can say that the square of the hypotenuse, that is square of this, is equal to the sum of the squares of the other two sides. So we have something like that. Okay, so PS squared, we have 8 squared here. Then PQ, we have 5 squared here. Then of course we are finding QS or SQ. So QS here squared. So there is 64, there is 25, and there is the length QS squared. So we have 64 minus 25. Then we have 8 equal to the length QR squared. So let us subtract 64 from 25. Then we take the square root straight ahead so that we move at a faster rate a bit. So minus 25, and then we have 39. So we take the square root of 39. Then that is what we have. We have 6.244 or 6.245. So first, when we subtract this from that, we get 39 here, and then to find QS, we take square root of both sides, and then when we do that, the length QS is equal to 6.245, that is the 3 decimal place, centimeters. All right, so from S to Q, the whole of this length is 6.245. I think so. Let me check it. 6.245. Okay, so to find this length we have to subtract 3.9 from 6.245. So we say 6.245 minus 3.9, then we have 2.345. okay, so SR is 2.345. all right, so this length here 2.345. so we can now go ahead and find this angle because we know this length. So the last step we do here is that we say, using the sine rule, we take the sine of this angle and divide it by the length that faces it. So we say sine 128 divided by the length 8 should be equal to, then we take the sine of this angle y and divide it by the length that faces it. So we say that is equal to sine y divided by 2.345. all right, I want to make y the subject. I want to find y, so I'm going to do half cross multiplication. I'll leave sine 128 out of 8 here, and I'll bring this up here so that I'll have times 2.345, but I will leave the sine y here so that I will simplify the term on the left. And let me do that here. I'm going to type the whole of this on the calculator so that we can move at a faster pace. So I will have sine 128, all right, out of 8, then we have times 2.345, and when I press on the equal sign I get 0.2309. so 0.231, let me put it that way, 0.231 equals sine y. So this implies that y is equal to the sine inverse of 0.231, and y is equal to, so let me take the sine inverse of the whole of the answer. So shift sine of the answer, and I'm getting 13.355. so I'm getting 13.355, and to the nearest whole number I'm getting 13 degrees. all right, so to the nearest whole number I'm getting 13 degrees. So you can see that we have been able to find the value of y. Initially we had the value of y to be 13 degrees when we used just the two right angle triangles, but you can as well use this scaling triangle by first finding this length, which is 2.345, and applying the sine rule. You will surely come to the same answer. So these are the two ways that you can solve this question. I hope you enjoyed this one too, and don't forget to subscribe if you have not done that already, and please click on the like button to help this video trend. Thank you very much, and I'll see you again.